Hello, Steve Collins with ACG Research, and welcome to another edition of the Hot Seat. Today, my guest is Craig Labovitz, and he's the general manager for Nokia Deepfield here in Ann Arbor, Michigan, my favorite college town. Craig, thank you for being with us today.
Thank you. Thanks for coming to Ann Arbor.
Yes, my pleasure. I am a U-Michigan grad after all, so it's always great to go back and see the old alma mater. So, Craig, we haven't had a chance to talk since last year at the Nokia IP Networks Reimagined event. And at that time, it was maybe 3 or 4 months after the acquisition with Nokia. So maybe a good place to start is to bring us up to speed on kind of what's transpired here at Deepfield and inside of Nokia since that time.
Yeah, sure. So it's been a busy year. I think over the last year, we've successfully completed the integration, which is, of course, lots of different processes. But beyond the integration, we've been able to take advantage of the resources. So we have new test facilities in Antwerp and other parts of the US and around the world, leveraging facilities. We've been able to leverage some of the partnerships with different business units within Nokia. I know we'll talk about FP4 coming up. So it really has been a lot of fun going from what had been a little startup with very limited resources to now having global test facilities, global research facilities. And at the same time, we've been continuing the investment in Deepfield. So while you can't see it on camera, our office has now doubled, and we're in now the second half of the office expansion, quickly filling up with new engineers here, as well as Antwerp. So very exciting, but certainly a very busy year as we've been growing the team and really taking advantage of all the newly available resources.
Yeah, that's great. It's always nice to go from startup mode to the benefits of a multi-billion-dollar corporation. Having done that once myself, I have an appreciation for the process. It can be a shock to the system, but also I think it can be very, very healthy to finally get the global scope that you probably weren't able to achieve when you were just Deepfield, right?
Yeah.
So at the Nokia event, it was the big unveiling of the FP4 chip, which is going to be the heart of the latest generation of the Nokia routers. And I was impressed. It's a really impressive piece of technology, has terabit flow processing capabilities, and then some very powerful, essentially packet intelligence and packet flow processing capabilities. And at the event, I know there was a lot of talk at a high level about looking forward to being able to integrate the capabilities of Deepfield with the capabilities of the FP4 chip. And I thought it might be interesting for you to elaborate on that a little bit more for our audience here.
Yeah. Well, I think the technology is quickly going from what was an announcement to reality. So the FP4 is now shipping and now in the hands of multiple customers around the world. And we are working quite closely with the FP4 engineering teams to make the integration with Deepfield a reality. So awful lot of work is involved, but we are spending time with both existing customers and new customers who are looking for some of the key advantages, and we can certainly speak towards those that come with the combination of the FP4 and Deepfield.
Yeah, maybe you could provide a little more color commentary in terms of some of the use cases, in terms of being able to extract information from the network via Deepfield and then use that to kind of intelligently program the network, specifically leveraging the capabilities of the FP4 chip itself.
Sure. So I think there's really two ways to think about it. One is new capabilities, and the other is just scale and for existing DDoS. With the latter, one of the things we've seen, of course, is growth in DDoS, growth in the botnets, growth in the IoT. Traditionally, DDoS has been something solved with standalone appliances. You gather a rack of standalone appliances and your data center, if you're a provider, you configure tunnels, MPLS or GRE. For each customer, you hand configure the technology. And, it's a fairly laborious, it's for very high-end customers.
Right.
And of course, you're dealing with Moore's Law, right? Every time the network grows, you need to grow the standalone appliances.
Right.
And as DDoS have grown and as the customers have grown, of just going from tens of customers, requiring DDoS to now thousands or all customers.
Right.
The question is, how do you transform DDoS from being an add-on to the network?
Right.
To being a building block of the network.
Right.
Certainly when you get to terabit speeds,
Right.
which we've seen in recent DDoS, it is really hard for this to be something you bolt on later.
Right.
So we're quite excited by the capability of the FP4 not to have DDoS protection be an afterthought, be an add-on, but be built in everywhere.
Right.
Be built in at the aggregation, at the peer, at the metro, and now afford the flexibility to block DDoS throughout the network as
Right.
part of the network.
So in that case, you'd be taking the visibility you gain via Deepfield into all those kind of malevolent endpoints out there that are hammering away to deny service. Learn about those endpoints and then learn those specific addresses and then program the FP4 chip to drop those packets on the fly as they transit the routers at terabit speeds.
Yeah, exactly. And of course, this is also a big change. In the past, networks were relatively simple. You had major national data centers where you interconnected with the rest of the internet. What we're seeing now is providers are doing interconnection throughout the network. In the metro, you'll have direct connections to all the major CDN,
Right.
to all the major hosting,
Right.
to all the major content.
Right.
So DDoS is not just coming through the
Right.
the 10 national data centers or
Right.
the few locations.
Right.
DDoS is coming everywhere in the network.
Right.
So you really do need to have that protection
Right.
everywhere. And then I think the second part of this is DDoS is also changing not only in its scale, but in its nature.
Mm-hmm.
When I started doing DDoS some 15, ever, a long time ago,
Right.
DDoS was typically coming something from foreign countries,
Right.
around the world. And it was coming from, different nation states and maybe now and then compromised servers.
Right.
With the advent of IoT, game has just changed completely.
Right.
We now have gone from a single PC in a home, which may not be secured,
Right.
to dozens, or in some cases, my home is 35,
Right. Right.
different devices that have IPs. So we really are seeing a very significant change in sort of the nature of the attacks. And we also sort of the sophistication.
Right.
So before, traffic used to come from a single server.
Right.
I'm watching a video, I would go to my Netscape server.
Right.
Today, of course, we're seeing DDoS and affect content delivery that's coming over much
Right.
more complex supply chain,
Right.
coming from much more complex, IoT devices.
Right.
So we're seeing providers now also start to look at technologies like Deepfield and the FP4 to provide ubiquitous
Right.
DDoS protection, but also to be able to deal with these new IoT attacks and these new attacks against broader swaths of the infrastructure.
Right. Right. So shifting gears a little bit, I know another whole set of use cases you were involved in with Deepfield was essentially network visibility for traffic engineering, being able to understand how the flows are traversing the appearing in transit networks. But of course, if you were just giving the operators a tool to get visibility into this, the workflows to kind of take advantage of that knowledge were largely manual, right? People would have to go in and reconfigure their networks to take advantage of the efficiencies they might gain. So I know, again, at the Nokia event, there was a lot of talk about integrating Deepfield with the Nokia software-defined networking platform, the NSP platform. So a lot of this can be automated. So you're basically talking about insight-driven network automation for traffic engineering. So maybe provide a little bit of an update on the progress you've made on that front as well.
Yeah, so we've been spending a lot of time on this as well. And as you note, I started my career where part of my job was changing BGP weights and communities and doing, it reminds me of assembly programming, trying to do traffic engineering by really low level. And most of it was trial and error. It was guesswork. I would change a weight on an IGP. I would change a BGP prepend and see if it diverted traffic.
Right.
Now, two things were happening. One is I had very low-level tools to do it.
Right.
The second is all traffic was the same. Bits were bits.
Right.
I didn't know what the traffic was. I just knew I was trying to offload an interface. I absolutely wasn't focused on QoE or security or anything else.
Right.
So I think the way we think about it, and again, I actually used to do assembly, and it was awful.
Yeah.
And I used to do BGP level, TE, traffic engineering, later MPLS. But it really is providing tools like NSP that provide some of the framework to be able to operate at a higher level, at a business level, at a level that makes sense and you can reason about your business and different constraints. The challenge is it is not just the visibility and moving traffic around. But in today, you really want to know what is that traffic.
Right.
Not all traffic is created equal, either from a QoE sensitivity or from a revenue or from a customer perspective.
Right.
So I think the combination of Deepfield with NSP provides, one, the tools. NSP provides the engine to manipulate the traffic at much higher using, SDN and all of the associated logic. And Deepfield now provides visibility into, is it your own video service? Is it OTT?
Right.
But really, really powerful tools to be able to meet specific business, specific quality, specific traffic engineering goals.
Right. Having programmed in assembly language and having looked at BGP traffic engineering, I can assure you BGP traffic engineering is far worse than programming in assembly language. There's still a lot of rocket science in the internet.
It is.
So maybe the last thing we can touch on is the Deepfield Cloud Genome concept, which when I first learned about it or heard about it for the first time, I came away impressed, but I don't think I had a full appreciation for the scale and the scope of what you've taken on in this mapping out of the internet supply chain.
Sure.
And for those of you who aren't familiar with the cloud genome, it's a way for these guys to go out and learn about what's going on out in the internet in terms of all the different endpoints and networks and kind of how they're all stitched together, essentially in a value chain. But I'd like Craig to talk about this in a little bit more detail because I think it's an impressive piece of engineering.
Yeah, sure. And the way I often describe it is, though we're not Google, but I always thought having Google level knowledge of content, of infrastructure, of servers, of individual IPs and data centers around the internet becomes really powerful to augment the security and traffic engineering use cases. So as you said, we talked many months ago, we start out basically doing Google-like discovery of every IP, combining commercial as well as public sources. Our initial focus was really on infrastructure. This is understanding CDN, understanding hosting, understanding content and OTT and video.
Right.
I think as we've done more work with FP4, our focus has shifted not just on the infrastructure, but on the security implications.
Sure.
Specifically, some of the denial of service attacks we've seen have been coming from IoT devices.
Right.
These would be poorly secured cameras, poorly secured cable modems, poorly secured screens, or a range of now security devices. So we have started to spend a lot more time on understanding all of these other devices out there in the internet. Particularly, it is really helpful when you see a very large-scale denial of service attack. It's not just blocking DNS, it's not just blocking traffic, but providing the tools now to block specific devices, which have all may have been compromised as an attack. Really a very unique capability, and a capability that also leverages some of the FP4. Typically, for given routers or other standalone appliances, you get thousands of things you can block, thousands of individual endpoints. We have just the capabilities are an order of magnitude larger that we're really excited about with the FP4 to block basically all types of a certain device on the internet.
So to do this, you have to go out and crawl the internet. How much of the internet do you see? How often are you scanning it? Give folks a little bit better feel for that quantitatively speaking.
Yeah. So we have servers running basically in all major regions, whether it be Asia, within China, within the former Soviet bloc, or Russia, throughout the U.S., Latin America. So we're doing active discovery globally. And yeah, it's again, much like someone like Google or others, it is dozens or hundreds of servers. It's an infrastructure that operates distributed across the world and is just continuously trying to learn what is happening in the internet, what our different IPs are doing. And we also combine this, as I said, with other both community-driven and commercial lists. So there's now a wealth of information, if you can synthesize it, about what are the known botnets, what are the known command and control nodes for different types of bots. what are the known compromised machines.
Yeah.
So really a wealth of information. And we really view a lot of our role as Deepfield is providing the glue to take in data from your network, to synthesize it with data that we help create,
Right.
combine it with other community-driven commercial sources,
Right.
to provide the tools for real-time visibility into your traffic,
Right.
real-time visibility into security, and then the controls to both affect QE goals, to
Right.
affect business goals and security goals like
Right.
block a DDoS.
Right, right. So just to recap for folks, I mean, we're looking at the combination of Nokia Deepfield as a product, the Nokia routers enabled by the FP4 chip, and then the Nokia NSP software, kind of tying all three of those together in an integrated fashion to both secure and ensure the performance of the network.
Yeah, and again, Nokia does sell each of those components individually, and will continue to do that.
Right.
But one of the things we were quite excited about, when we joined Nokia, was the ability to leverage all of these additional capabilities.
Right, right. Well, that's great. I think that's today's edition of the Hot Seat. Again, I want to thank you
thanks so much
for taking the time, and great job here at Deepfield. Look forward to hearing more good things.
Yep,
Thank
you
you.
for coming.